Hello again, and have you seen the last two videos I did on this TD-H8 TID radio? I may be flogging it to death a bit to do another video on it, but just for completeness, what I want to do really is to measure the RF power at the various settings on VHF and UHF with something fairly accurate, which is this Agilent RF power meter, which relies on a sensor plugged in there, and the radio is connected to a 30 dB attenuator, because if I connected my power sensor to the radio it would destroy the power sensor, and I wouldn't be very happy if I destroyed my power sensor. So in other words, the power sensor is rated at plus 20 dBm and the radio is plus 40 dBm 10 watts in theory, and a 30 dB power attenuator takes it down to a maximum output of plus 10, and that has all been compensated for in the Agilent power meter, so it will read that offset and it subtracts the 30 dB offset. So without further ado, on with the excitement, and I'll screw the radio to the power attenuator. Okay, so the radio is now screwed in. I think you'll agree there's virtually zero loss through that connector. So the radio is specified at 10 watts on high power on VHF and UHF, and I think it's 5 watts medium and 2 watts on low power. So let's try it on high power on VHF, 2 meters. Let's look up there and I'll transmit 10.1 watts. Can't say fairer than that. That's good enough for me. I'd take that any day. I think in practice, because of the high current draw, that 10 watts is going to drop off fairly quickly as the battery goes down. Now I've got to get into this complicated menu structure, and I've got to do menu down to mid power, menu again, exit. So now we should be reading 5 watts in theory. Zoom in again, and we're only getting 3.4. Not a massive difference compared to 5, probably hardly noticeable in practice, but really I would have liked to seen 5 there. Okay, let's go for all this nonsense again with the menu. Menu, transmit power, menu. Oh god, this is tedious, it really is. Menu. Done. Oh no, it's done it again. Low. Eventually I got to low. Right, low power. 2 watts, I'm told. 1.4 watts. Not too far off 2 watts, I'll take that. And I would have liked to see a lower level than that really on low power. 1 watt would be plenty on low power. In fact 100 milliwatts would be nice on lowest power, but I'll take that anyway. So that's VHF for you, but I'm most impressed that it can produce 10 watts. In fact, I was using it earlier, and after you talked on it for a couple of minutes it becomes quite a nice hand warmer, because as we all know, power amplifiers are not 100% efficient. You'd be lucky to get 55% efficiency on a power amplifier. So if you're putting out 10 watts, you've got a fair bit more wasted heat to get rid of. Enough waffling, I'll just get it set up on UHF. Right, I've now got it on well, a repeater frequency. I think I might change that actually. Right, I've now got it set to 433 megahertz because I think most of the activity in the UK is around the lower end of the band. Let's go up here and transmit 10.7, 10.5, that's even better than VHF. I think that's very impressive. Okay, now I've got to change to medium, menu, menu, mid, menu, exit. Okay, let's try it on mid power. Supposed to be 5 watts, 5.4 watts, pretty impressive. It's interesting that it puts out more power on UHF than it did on VHF. Anyway, let's do the low power. Always a case of pressing the wrong buttons. Exit. Right, low power on UHF. .64, 2.5. Yeah, well, it's supposed to be 2. I'll take that. 2.5 watts. That's good. So, I've done measurements on many Chinese radios in the past, and some of them meet their power specifications, and but some don't. I have an 8 watt Bofang which only manages 6.5 watts, but I'm quite very impressed that this more or less meets its power specifications, especially the 10 watt output. Okay, now we've done the power test. I think I will connect up to the spectrum analyzer and we'll look for some spurious signals if we can find any. Okay, so now we've got it connected to the spectrum analyzer, again using a 30 dB power attenuator, otherwise I'd destroy my spectrum analyzer. So let's get in on the screen, try and get it as clear as I can. Now, what we're looking at here, I'm going to scan between 100, start frequency of 100, marker, stop frequency of 1 gigahertz. We'll see what happens. Reference level set to 10 dBm, so transmitting at plus 40 dBm from the radio is going to bring it right up to plus 10 on the spectrum analyzer. Let's go ahead and do it then. Well, that's an interesting signal. What's that doing there? That's the main carrier, and we're getting something weird at 217 megahertz, but it doesn't stay around long enough to measure. I don't know what that's all about, but I'm not going to worry too much about that because it doesn't last long enough to be worrying. Just a bit strange, that's all. So apart from that, and what am I transmitting on? 145 megahertz. What's the second harmonic? 290? I set center frequency 290 megahertz. Should be there. Let's reduce the span a bit. Second harmonic I'm looking for. I could do some, yeah, I'm looking at, what I've done is I've reduced the noise level by decreasing the resolution bandwidth. So if you remember, we were right up at here with the main carrier at plus 10, and the second harmonic is 20, 30, 40, 50, 60, 70. It's over 70 dBs down. I think that's quite impressive. Now, what's the third harmonic of 145? There's no way I can work that out in my head. Well, apparently it's 435, so let's dial in 435 and try again. See if there's a third harmonic there. Oh, there is something, but it's way, way, way down. It's 65 dBs down below 0 dBm, so that's 75 dBs below the carrier. That's amazingly good. I've never seen any handheld radio produce such a good harmonic performance as that. Some radios costing 100 times, not 100 times, 50 times, maybe 100 times more than that radio. I've seen worse harmonics than this. So I think that really is superb on VHF anyway. I haven't done UHF yet. So they've got their low pass filtering sorted very, very well. Let's try it on UHF. Okay, this time I've set the radio to transmit on 433 MHz and I'm scanning between 400 and 1.5 GHz because the third harmonic's going to be up around getting close to that. So let's transmit and see what happens. It's clean as a whistle, isn't it? That's amazing. So where's my calculator? Because I can't do things like this. 433 times 2 is 866. Let's try center frequency 866 megahertz. So reduce the span a bit, give me a bit more sensitivity, and let's reduce the bandwidth a bit, resolution bandwidth, give a lower noise floor and transmit again. Here we go, we've got a signal at minus 58, minus 60, so that's basically 70 dB, getting on 70 dB down on the plus 10 dBm carrier. I mean, you look at this, that's 10, 20, 30, 40, 50, 60, nearly 70 dBs down on the second harmonic. Absolutely excellent, that is. Now, what's the third harmonic? Plus 433 is 1299. 1299. Oh, too many nines. How do you do the back? Megahertz. Looking for the third harmonic now. Still there, but it's very, very, very weak. Peak. Minus 56 down on 0 is 66 dBs down on plus 10. So I think that's absolutely really well filtered, this radio. It's just that it did have that spurious peak that appeared on VHF for a few seconds. I'm not going to worry too much about that unless it's a sign of instability and it's going to explode one day. But all in all, I'm full of admiration for their designers. Okay, they couldn't get the display right, the display radiates noise, but at least they've done the RF bit very, very well. I can't really test things like deviation. I haven't got a deviation meter, so there's no point in trying to do things with that. I mean, I could look at it on the spectrum analyzer and see what it looks like, but could have a quick look, I guess. I'm back on 2 meters. Okay, I'm going to try and have a look at the FM deviation on a spectrum analyzer. I'm spanning 50 kilohertz now. It's got to be quite narrow to see a small deviation from the carrier, and I think I'm going to put it on max hold to do this, and I'm going to whistle into it, or try to. First of all I'll transmit, then that was a loud whistle, and as you can see, if this is 50 kilohertz from there to there, we are, oh, don't do that, oh, don't do that, do it again. That's quite a loud whistle though, it's not a normal speaking voice. I'll go to marker, and I did delta marker. What would you normally have as a deviation? On wide, maybe 3-4 kilohertz, which is what that is, difference between the carrier and that. But you know, you can see how the FM modulation drops off as it gets further away from the carrier. I can do the same that side, around about 3-4 kilohertz. It's still producing deviation but dropping off steadily. So I think that's good enough. It's a chance to play with my my equipment anyway, which is always good. All in all, it's the most impressive radio. Not as cheap as some, but really good performance apart from the colour display, which of course I've done a video on, which radiates RF noise. I wish they would have fixed that before they'd put it on the market, this radio. And don't know what the answer to that one is. I hope they'll redesign it at some point in the future, and that would make it a really good radio, I think. Did I say earlier I had some contacts on it earlier, standing at the top of the garden, talking into the repeater 40 miles away, and they said the audio was really good on it, so that's good. Anyway, thanks for watching, bye for now.